means that when you, number three purpose is heating to get rid of the water. Like you're cooking and you want the water to reduce, maybe because it'll make the soup nicer, something like that, right? I'm going to get rid of the water by heating the water. That makes sense so far? Make sense so far?
Get it.
Now, what does saturation mean? I'm going to heat it extremely until the water is so gone, right? The water is so gone, but the water cannot be fully gone. When the water remains a little bit, it becomes very difficult to get rid of the water for a reason they don't tell you. They just tell you that you cannot get rid of the water fully, if only you could. So what do you do is just when you put in a glass rod, that's the normal thing you have in the practical lab. You put it in, and suddenly the zinc sulfate will simply attach themselves to the glass rod because the solution is so concentrated. The so concentrated solution is called saturated. That means if this is a salt water, the salt is super salty. If you just fish for it with a glass rod, the crystal will just form itself. And crystals are pure zinc sulfate, so to speak.
Okay, so I must test. So I must test whether it's saturated enough.
This test doesn't mean anything complicated. This test simply means just poke it with a glass rod. If it doesn't happen, continue heating. That's what it means. That's actually what it means.
I must heat until this crystal
saturated. Yeah, that's why in the standard answer, you don't say test, you just combine 3 and 4, you say heat until saturated. Usually that's acceptable. Yeah, but in a lab, you want to know how, this one how lah. I mean, it's a good information. Okay, and yeah. Now, once it is saturated, then you just leave it cool, and then the crystal will form automatically on the beaker because it formed on the glass rod, it will form the beaker when you let it go on, definitely, blah, 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 you have it. Number 7, also very important, right? Okay. Okay, so far, look at it clearly, slowly. Any question? Tell me lah.
Okay. Wait, the 2 reactive metals are mainly the group 1 metals, right? Because they can.
Yeah. Sometimes group 2, calcium, but okay. The point is the metal will react with water, so no chance to react with what you're supposed to react it with. Annoying, so it's annoying. Yeah. Basically, you'll be titrating them. Anyway. So far, so good at your quiz. So far, so good. Now, look at the acid with an insoluble base. That means not the metal, but the oxide of the metal. Don't know why they choose this, yeah. But look at the 1, 2, 3, 4, 5, 6, 7. Actually, got different or not from the first example. Any difference?
React access with the nose the same. This filter then crystallize. The react can have accents. Okay.
Any difference?
Not much.
Yep, you're right. Not much. Okay, not much. So he's giving an example where there isn't much difference. This one will work just the same one. You'll be fine. And the reason is very simple because CuS, CuO. CuO is the solid and the CuO will also be excess. Same thing what? Because I want to make sure that the aqueous is gone. Same thing what? Okay. The rest is the same. Now it changes, right? Now he wants to make the salt aqueous, right? The salt will be aqueous. Yeah. There's an acid which is aqueous, and then there's a carbonate. Don't know why they changed the solid to carbonate, but it's still solid. And look at that, the magnesium carbonate also excess. Same thing one. Really, no, it's just the same thing. Correct. Equals solid, make that solid excess, your equals whatever it is, same lah, same. Salt is soluble, starting metal soluble, titration, which is what I say to you lah.
Insoluble base.
Okay. The acid is, because they assume acid is soluble one. In O level, that's true. All acid used in O level is always soluble. Is there acid which is not soluble? Close my eyes, say no, right? Right. Soluble base, it is no longer solid, it's soluble. Then you titrate low so that everything is gone.
Got it.
No surprises. Okay, Kyoko, the method I show you is the standard and always like that one method. It becomes very standard once you get used to it.
Okay.
You need to practice this again.
Yeah.
Find a question which is differentiate and then integrate, and then see for yourself that is it true what Kak Philip say, is it true that it is always the same, right?
Okay.
If you could do that lah. Wait, what? No, this question 13 will not need that technique, but it is also an important thing to practice. You can do it first, and then let's go back to the previous one. Yeah.
Okay.
Are you okay? And
yeah, I'm fine.
We need to memorize part 1 and part 2. Well, yes, you need. Those are the details, yes. How to do it, yes, you need to. And you will need to do this in practical anyway. So cover both sides, you know.
Got it. So the method is just memorization.
I'm sorry, which one's memorization?
The method.
The steps. Yeah, the steps. What I don't want you to memorize is the why before the steps. Like you know, why titration, why excess data. That one don't memorize.
Okay, got it.
Can I go to the toilet first?
Yes, please.
Okay.
Oh yeah, one thing I want to clarify is how to write the ionic equation, because I still don't really get it. Because I know the chemical one, but the ionic one I don't know.
Yeah. Surprisingly, it's very simple. Now, I told you last time, everything equals split to positive and negative. Liquid, gas, and solid don't split. Correct? Simple lah. Equals split. That is the most important effect of being equals, right? So look at this in your mind. Let's say you don't write. Let's say you write. In your mind, HNO3 is not HNO3, but what is it?
H plus NO3
minus.
Yeah.
Good. And then NaOH?
NaOH is Na-OH minus.
Na plus OH minus. And then NaNO3?
Sorry?
NaNO3
is Na plus NO3 minus.
In your mind, easy to do, right? Immediately, left side cancel with right side. What is the same? NO3 minus left hand side, NO3 minus right hand side, cancel.
Okay.
Na plus left hand side, right side, cancel.
Got it.
Yes. So what is left in the left hand side? You tell me.
H plus.
Good. Plus.
And, OH.
Minus. Good. Both equals. Arrow.
H2O.
That is your ionic equation. Do you understand?
That's it. I have to write my state symbols.
Correct. Oh, you have to write your state symbol, and that's it.
Okay, got it.
Now, the ionic equation tells you something. The ionic equation tells you the real thing. Actually, the only thing that happened is H plus meets OH minus become H2O. The NaNO3, the NaO3 minus is cancelled not because it's gone. It means it's still just fly around in water. It's just happily dissolved in water. Just flying around here and there. Nothing happens to NaNO3 minus and nothing happens to Na plus. Because before reaction, separated. After reaction, also separated. Just that the writing makes it very nice. Oh, wow, Na plus combined with NO3 minus. That's not true. It's still both separate. But when H plus meets OH minus, they no longer become separate, they become water, which is something called a big deal. That's called neutralization.
Okay.
Right. So ionic equation is important. They will ask for it every time. It also has a meaning. So hopefully we can practice. This 1, 2, 3 will be something that you will need to memorize and you will need to do in practicals. You don't have to memorize that. And you can if you want. There's still 4 and 5, right? And then you will then titrate. Okay. So after titration, all those stuff.
I think, I did titration once in lab, but it's only with the methyl orange. That's it.
You probably just change the indicator. They will actually tell you which indicator, those kind of stuff. If there's a question here.
Not really.
Okay, all right. Then you do have to memorize this, but on your exam. Okay.
Precipitation.
What does it mean? It means that the target salt is solid. The target salt is solid. According to your memorization, all the salt they listed down here are definitely the insoluble salt.
Okay.
Definitely. Right. So nothing new here, just the same memorization. Right. Now look at the reaction. It is extremely not surprising that the both reactant is aqueous. It's not surprising at all. That one I want you to understand. Why? If you want to make a solid salt, you better start with 2 aqueous. Why?
Not sure.
Because they won't contaminate the solid.
Oh.
No matter who is in excess. No matter. Doesn't matter who is in excess. Both are aqueous. Whoever is in excess will be aqueous. You won't contaminate the solid. Plus, the other result guy is also aqueous. Also won't contaminate the solid. Also won't.
Okay, got it.
Same logic as the previous one. Why don't your partial fraction is great, Yoko. Very good. Do they tell you which one is excess? They don't. Somebody is in excess because it's not titration. Nobody cares, right? Because we don't have to care. Oh, did you tell that the excess is sodium sulfate? Well, doesn't matter. Are you okay, Andrew? There's just a slight difference here. It's like you notice that the steps are shorter. This is like the easiest thing to do. It is true that practically this is the easiest thing to do because the result is already solid. It's so easy to get, so to speak. That's why.
After I just rinse it, you can just collect.
Yeah, just leave it to dry. As in, basically, just dry it. Ta-da! It's already solid. That's the reason why it's easy.
I get it. Do what happened?
Yeah. Try again. Maybe just because we are supposed to. This is basically it, lah. So just make sure that the last two one is okay. Looking good, Yoko. Looking good. All looks good. Try zero. Try zero. Is it easier, Yoko, if it is zero? You can use zero, you can use something that is easy, you see. So I'm saying
Okay.
try zero. Yeah, try zero. Definitely do something easy next time. So if it doesn't work, Andrew, no problem. Probably nothing much is missed. Just permit lah when. I'm more curious what your teacher give you lah. So your teacher give you this, but your teacher give you some sort of paper also, man. I'm curious about that now.
Oh yeah.
Once you're happy with this, okay. I want to see what written things he give you. Then I know whether it is appropriate or not. I guess. When she explained, never mind. Don't worry too much. Now, may I know when he explained, he uses your printed worksheet or he uses the slide just now?
He uses neither. He just talks.
He talks. He talks.
He talks. Scribbles on the board and that's it.
Huh. Okay. Sure. All right. Okay.
Okay, I'll get the
worksheet thingy. Yep. Okay. Right, Kyoko, the zero is relatively easy lah. Fair enough, right? So it's good to use lah, yeah? Good to use. Okay, so what's the point of doing partial fraction? Because the integration would be much easier lah, right? Yeah. And you do, oh yeah, you did this before with Kak Urayan. Yeah, okay. Let me see. See. Time. Andrew, are you okay? Oh, all right. Okay, got it. Oh, this is the same thing as last time.
Yes, but there's a few more to it.
Okay, tell me what your teacher did, sir. Tell me. When did he give you the slide? The one that we talked about this time?
I think last week.
Okay, last week. When did he give you this thing?
Last week too.
Did he start talking about the chapter after giving you all that, or before giving you all that, or in the middle? Or how does that work?
Before.
So he starts a new chapter. He tells you that this is an acid, base, and salt chapter. He talks about it, and then he gives you this worksheet and the slide. That's why you say he doesn't use the slide or because he doesn't use the worksheet, because the worksheet is not an explanation. The worksheet is a practice.
Yeah. He doesn't use the slides, like that's what I was saying.
Right. So after he explains, and let's say you know when it ends, right? Even though you don't follow very well, you know when it ends, then what is the expectation? He expects you to kind of do these questions and then submit to him. That's what has been happening.
Yeah, I guess.
And when doing this worksheet is when you say you don't get much, and then after the marking, you also don't understand much.
Yeah.
Why is that so? Because sometimes teacher will discuss the question and discuss why the answer is like this and like that.
I think he more like briefly goes through it, just gives the answers, we copy it down everything.
So that's the standard thing that happens. Every time is like that one.
Most time, yeah.
So this time, this time after holiday, that is what's going to happen.
Yeah, I think this will happen.
Because this one haven't been discussed, right? Haven't. So he expects you to just do this during holiday, and after holiday, discuss a bit, and then move on to the next chapter.
Yeah, I guess.
Okay. Now, basically, we finished the explanation beside the oxide one. I don't see any oxide slides, so I'm a bit confused right now. That should be in, but other than that, nothing at all. Nothing that we left behind. You're supposed to be able to do this. And if we do this with understanding, then we can say we are ahead of the class.
Yes, I think so.
Good. Okay. So it's already 1.5 hours. Okay. If we stop now, try. Let's try 6. Let me see. Yeah.
Solution to okay.
This is not very easy.
This is about the transition.
Okay. Wow. Okay. Let me just let me just explain a few things. Okay. The indigestion tablet. I take it that you have not eaten this an indigestion tablet before.
Is it to increase acidity in the stomach?
No, to decrease.
Oh.
Because indigestion usually involves extreme or out of control acid in the stomach. So indigestion tablet is actually alkaline. It's actually base. I hope that makes sense. It neutralizes extra acids, right? Neutralizes. Okay. Now, normally you will kind of take the base not in excess. If you take the base in excess, you will neutralize every acid in your stomach, which is bad. That's not what you want. But you want to neutralize enough, you still have remaining acid. So in this case, we say that we don't take too much, we just take enough, right? Here, the situation is a bit different. We are not using our stomach, we're just using acid. And he said titration. What's the meaning of titration?
Both are equals.
Both are equals, true, and it means that both will be like exact same mid, boom, gone, something like that.
Yep.
There's that implication, right? There's that implication. Then you look at the table, and student 1, 2, 3, 4 definitely have a very similar titration value, right? Makes sense, right? Because only one tablet, only one tablet. each. And suddenly, student 5 have a higher titration value. That means you need more acid or more tablet, just to check with you.
Titration value.
What does that mean?
Is to put
you need more what than the other students?
Indigestion tablet. Because you put
water. He put more acid. Because the wording is they were then titrated. They then titrated the solution. The solution is the indigestion tablet. Everybody won. But they titrated with acid. So the titration value must be the how many drop of acid must you titrate.
Okay.
So that means student 5 needs to titrate more. Yeah. And why? The question now makes sense. Like, hey, how come? How come the question 5 so different? You know?
There's more indigestion tablet, so it's more alkali, so you have to add more acid to neutralize it. So
but he limit the indigestion tablet to 1 already. Everybody just 1. Just to be clear. It's not more indigestion tablet. The question clearly states. So you think about it. Now, Kyoko, obviously you did very well. Yeah? I think you did it a bit long, but for now, since you did it well, that's the most important thing, right? Plus, the marks should justify. The marks should justify the length of the work. Because not just it's long, you have to do it slowly also in exam. So they'll give you like in total 5 to 6 marks, which is reasonable. So no complaints about your speed, right? I'm very happy that you're correct. Yeah. So you choose question 16. Question 16 is definitely the kind of question like question that thing like the one. Can you start? Can you start question 16? Ignore 17.
Is D correct?
Okay, let me check. The titration flask was washed out with a tablet solution. With a tablet solution. What does that mean? I'm going to copy this because another student came in. Let me copy this and then let me reply using WhatsApp. Right? Okay. Let me just reply using WhatsApp and I'll tell you what I think. Okay. So if there's no other changes, I will see you after the trip, right?
Yep.
We'll probably do a bit more to catch up with the class, to get ahead, and maybe to cover the one topic ahead. Okay. Okay, go for both chemistry and physics. Okay. Good job for today, and I'll see you. Bye-bye. Okay, Ainesh, I can see you. Can you hear?
Hello.
Yeah. Okay. So, Ainesh, what's the plan today?
Can we do
as in, yeah. I'm sorry. I take it that your plan was 45 minutes, right?
Oh, no, I mean, I want to do 30 minutes because I'm still recovering. And like I had a long day at school. That was okay.
Okay. So what do you do?
On Thursday. Are you free on Thursdays?
What else can I say? That's all you have, look. That's all you have, right? That's all you have. So do as much as you can, right? Before you go for your trip.
Yeah. So can we cover set notation for today and tomorrow?
I'm okay. Show me what you got.
Because
right, Kyoko,
like
can you? I know this. We have to. We have to do that. Right. Okay. Show me what you got quickly. Kyoko, can you differentiate that?
I don't think so.
What's the differentiation of ln x?
1 over x.
Good. So the differentiation of ln secant x is first thing first. Part 1 is 1 over secant x. Okay. First thing first. not 1 over cosine x. Can you?
Oh.
And then times chain rule, correct or not? We're supposed to use chain rule here, not product rule, not quotient rule. Okay. Times the differentiation of secant x. What's the differentiation of secant x? That's not easy to answer. What is the differentiation of secant x? Okay. So kindly do differentiation of secant x. Kindly do it. Right? You might need some rules. Remember, back to differentiation, you can use chain rule, product rule, or quotient rule to get through anything. But right now, you need differentiation of secant x. So please do that separately first. Can you do that? Okay. If you're stuck, do it. Shall we starting? I mean, we have 15 minutes left.
No.
Right. Okay. Got it. Okay. Can we ignore page 1?
Okay.
Unless you want to ask. Okay.
I mean, I want to ask about the symbols, but yeah, I'll just move on.
Yeah, you'll get the symbols later. Yeah. Very good question. You'll get it later. Blah, 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 blah. All these are important, but I'm getting straight to the point. Yeah. Regarding the questions, regarding the questions. No, don't flip. Yeah, there you go. Example 2, example 3. Are you okay with the question or not?
No, I don't understand what this means. I was just copying down stuff in class. I couldn't understand.
Do you understand A?
Yeah.
Okay, 5 is not a member of that group. Totally makes sense, right? Bus is a member of BUS. So they're being strict here. Bus is a word, and B and U and S is also a word, and so bus taken as a whole is not a member of B, U, and S. They're being very strict here. This is not important. I just tell you why it's wrong. Okay. Bus is not B, is not U, is not S. Okay. Stop. Okay, that's question B. Now, question C, 4 is not part of or is not a member of the group of x equals to 2k, where k is a member of big Z. Now, you need to know what big Z is. They're going to use it a lot here.
Okay.
What is big Z?
I always forget, so I just refer to this.
Check it out. Yeah, you do need to remember it from now on. Okay, set of all integers. So what is an integer? That's the important thing.
Integer.
Yeah, you need to know what's an integer. So Z is all whole numbers. Okay.
Integer.
Negative number included or not?
No.
It is because look at the bottom one. Look at the bottom one. We add positive on the top right of Z to indicate positive integer. That means if we just say integer, the negative one also included.
What about zero?
Okay? That's a very good question. Some people include, some people don't. Now, looking at n, your teacher's philosophy is 0 not included because 0 is included in the n. So 0 is not included in the Z.
Okay. Regardless
Would you
of
please write that down?
Okay, sure.
Regardless of what?
Regardless of whether they're the plus or minus.
Yeah. So please explain that to yourself in this paper right now. What is Z? Because Z is the most commonly used thing. You write down first. Kyoko. Yeah, Kyoko. Yeah, okay, Kyoko. So, Kyoko, this will be here. Am I correct? Times sine x over cosine x squared. Now, is this okay? This is the differentiation of 1. No? Are you okay? I'm just using chain rule here.
Wait, sorry. What?
Okay, you differentiate second x, right? You differentiate second x. So I'm going to put it here. So the differentiation of ln second x is 1 over second x times the differentiation of second x. That will be our chain rule.
Oh, okay.
Is this okay or not? This is simple. This is applying chain rule. You sure you're okay?
Mm.
Okay. Then tell me what's 1 over second x is. Okay, let's go back to the next page, Ines. What is it? 1 over cosine x, which is? Figure it out, please. Using a calculator also fine. So, Ines, so x equals to 2k. K is every integer. So, minus 1, 1, 2, 3, 4, right? The effect of times 2 is what? 2, 1, 2, 3, 4, 5, 6. The effect of times 2 is? 1, 2, 3, 4 becomes?
1 and 2.
Okay, continue. So 1, 2, 3, 4 becomes times 2.
1, 2, 3, 4, 1, 2, 3, 4. No?
1, 2, 3, 4 times 2 is 2, 4, 6, 8. Are you okay or not?
Okay.
Clear, yeah? So x is 2, 4, 6, 8, 10, 12. The point is it's an even number. I think that's its point. Just say it in a very fancy way. Is 4 a member of even number or not?
I mean, yeah.
Okay, so are you okay with YC is false?
Yes.
You clear? Would you like to write down? Is it important? Feel free to. Feel free to. I mean, as an example, x equals to 2k is already slightly advanced. I feel. So I feel that it deserves some writing.
Yeah, actually, I'm not x equals to 2k. That means k.
Anish, your phone, please. Your phone, please.
Yeah, okay.
Right. Kyoko, are you okay?
Hello?
We are done with part 1, no? Yes, Anish.
Yeah. Okay, so again, actually, can you just explain this to me again?
You are delaying things a lot, Anish. Tell me what you don't understand. Kyoko, continue with part 2, please.
I'm just not super clarified. I want to make this. I want to make sure I'm clear about this first, because I always
You explain what you understand. You explain what you understand quickly.
That x equals to 2k, and
yeah, I didn't start with that. I start with k.
Yeah, so that means k has to be even number.
No, k is not even number. K is z. What is z?
Integer.
Which is?
Whole number.
Yeah, which is just write down lah. Just write down. Just write down what's the whole number. This is math. This is not English. K is z is what? No, as in write down the numbers.
Oh.
Right? It's not z plus, yeah. So -1, -2, -3 also included. So it's +-1, +-2, +-3 and all. Right?
Yeah.
That's k. K is z lah. Simple, right? So 2k. What does 2k become? 2k is now plus minus.
Okay.
Something like that. So something like that. Yoko, can you do part 2? Because I think we need part 2.
Oh.
Yoko. And okay, I'm gonna.
Is it product rule?
I mean, it looks like a multiplication, so I think that's a good bet. Would that be okay?
Okay.
Yeah, give it a try. Okay, Ainesh, what you did just now is a working, and this working, I think, is what we need. I think thinking about the phrase whole number doesn't help you. Certainly it doesn't help me. Writing down the numbers seems to be helping me. I think it also helps you. Okay?
Yeah.
Right. So if we are we're feeling amiss, I guess that's what we do, right? Rather than memorizing that z is integer, it probably doesn't even mean much, right? Now, example 3. Okay, x is between 5 and 6, and x is supposed to be an integer. That's English law. Do you understand why a is nothing? If you don't, you tell me. Don't say yes if you don't.
A equals to empty set. Oh, because there's no integer between 5 and 6.
Correct. Absolutely. Correct. Now try D lah. Try figure out B. What is big R? Big R is also an important thing, so you just take a peek. Just take a peek. What is big R? If you don't understand big R, please tell me. Very important.
All real numbers.
What does that mean, right? What does that mean? Do you understand what I mean? You don't memorize real number. That's useless.
Okay, I don't know what that means.
Every possible number that you can think of. I mean it.
Pi.
Fraction, in. Cert, in. Pi, in. E, in.
So any number.
Real numbers are any number that you can think of right now.
Negative, positive.
Because negative, positive, fraction, decimal,
Zero.
infinite, cert, pi, e, everything.
Zero also, right? Okay.
Zero also. So real number is really everything that you can think of. Okay, Kyoko, good job so far, right? That's clear. That's good, right? Now part 3. Part 3 will need the technique that I apply, right? Right? And it is not a coincidence that what he wants is here. It's not a coincidence at all. Look at what I apply, and I want you to apply it.
Okay.
Okay. Again, it's not a coincidence. It is supposed to be like that. Okay. So Aine, I'm sorry. What do you write? Anything? No exception. Okay. For now, that will be totally fine. So look at the previous question. So what is he saying? So this. Be no tricks lah. Can you accept it?
Yeah.
Okay. Right. So that's it lah. Okay. Nothing weird there. C. I see that you do some working. That's great actually.
I just copied this.
Correct. But let's pretend that there's no working there. So he's saying 9, 4x, 33, right? I think the best working is the one on the right low. I think they kind of make it nice to us from 4x into x. If you understand that working, actually, I think that's it. That's really it.
Oh, okay, actually, no, I understand this.
Okay, you okay?
Yeah.
Okay, then look at D.
Yep, I understand this.
Right. So the n is 2. So your 2n is 4. So is it? Okay. So seems like normal math. I'll call C and D very normal math. Right. Okay. So let's continue. You're saying? Sorry, you're saying?
Are these exam level or just basic stuff?
Not so above the basic stuff. The topic doesn't just go slightly further than this. I would probably say so. I'll probably say so. Their purpose is to test your position, not position, to test whether you're a good counter or not. That is where you may have problem. Right? Okay. Yeah. Do you understand what's A? Like, does it make sense? The answer is correct, but do you understand it?
I mean, yeah, I guess.
If they never tell you it's a prime number, do you realize that 2, 3, 5, 7, 11, 13, are prime numbers?
I will hope so. Probably, actually.
That would be nice.
Is this correct?
It's a set of cube numbers. Yep. You're absolutely right. Okay.
No, not positive, right? Cube numbers can only be positive.
No, it can be negative, right? It can be. So if it's negative, then it'll be negative. Positive. Oh God, but you're going in details and they're looking for it. I don't have to remind you that you have to think about the positive and negative. That's something good. That's something good. Okay. This question, this part 2, the one below, is a very simple thing. Just read it first. If you don't understand, let's talk about it. Very, very simple, huh? Kyoko, are you stuck somehow?
How do you do the pi? And
the integration of tangent x is not secant square. This is wrong. Yeah? The differentiation of tangent x. Please don't mix them, please.
Okay.
The integration of tangent x is not secant square x.
Okay.
Right? What is the integration of tangent x? Well, they say part 1 and part 2. Shouldn't you be looking at, part 1 and part 2? I'm saying the integration of tangent x is not easy. Either they help you or it's kind of impossible to do. Did they help you somehow? Ainesh, are you okay? N is just number of elements. I mean, let's just be done with it.
Yeah.
So look at example 4. Let's look at example 4. Example 4a, right? What's the n of m?
Sorry? N of n.
The small n is what?
Oh, number of elements of m.
Good. Number of elements of m. What is it?
10.
Yeah, good. Okay, you got it. That's n of m. 10. Okay.
Okay.
Okay. Kyoko, look at part 1. Kyoko, look at part 1. Kyoko, look at part 1. So whenever they give you English, you would notice this. For example, G is English, H is English, and J is English. Whenever they give you English, you just put in the numbers. If not, it will be very difficult to analyze. Would that make some sense? Anish?
Mm? Yeah.
Did you hear what I said?
No.
Whenever they give you English, G, H, and J, follow me?
Yeah.
You put in the numbers, then you start analyzing, not before. Put in the numbers for H and J, please. Yoko, do you understand?
No.
Integration of tangent x is difficult. You seem to think that it's doable. Let me put it another way. Integration of tangent x is supposed to be impossible for O-level students, but you seem to have a hope that you can do it. I mean, the previous example can do that. This one, I'm telling you, your feeling is wrong. Integration of tangent x cannot be done by an O-level student. Why? Do you know why? You need to know why. If not, then you will not be able to think that it's impossible. The reason is very simple. Look at this guy. Look at this guy. There is no product, there's no quotient rule for integration.
Yeah.
That is the reason why. Will this be okay, Kyoko? That is enough reason to think that integration of tangent x is impossible unless they help us. So it is their obligation to help us. This is a very important thing.
Yeah.
You need to know the limits. So if they don't help us or we don't see their help, we cannot do it one. That's the concept. So did they help you? Because they are supposed to help you in this kind of situation.
Oh, so it's the reverse of
Part one.
so it's second x.
Yes. Yes.
Oh.
That means they did help you and we have to use it because it is impossible.
Okay.
Very important, yeah. Very important, yeah. That's the whole logic, lah.
Okay.
Okay, good, Ines. You got your J, you got your H. Yeah, you get your H, lah. At this point, you already know who are equal sets, look. It's kind of not very difficult to see.
Yeah.
Like who are, okay, for example, H equals to J. No wonder your teacher write down that way, lah. No wonder. Okay. Okay. Why is G equals to I? Why is G equals to I?
Because prime numbers power the times 2, 3, 5, 7, 7.
Yeah. In a sense that it is obvious lah once you write down.
Yeah.
So next time, I expect you to write it down automatically. You don't rely on the English, you rely on the numbers lah, basically lah. That's what it means lah. Okay?
Okay.
Okay. So time is up. Let's do one more. Let's just flip. Yeah, just let's figure out A and B, and then okay, I mean that's all we can do today.
Okay. Finite or infinite? I mean, what? Aren't these both finite?
No. Again, list down. Yeah, the B is infinite. The A is finite. But you only know by listing it down. If you list down in your mind, I'm sure lah. Do you know why A is finite and B is not finite at all?
Because it's an endpoint and it's what's n? So.
Okay, what is n? You just look at it lah. You don't have to remember. Okay.
What's natural numbers?
Yeah, they give you the example. Never mind the definition of natural number. Just look at the content lah.
Oh, just this. So just positive numbers.
Positive integer plus 0 because 0 is not included in positive number.
I see.
So dot to 999. Okay, now that looks fine. Why are you including 1000?
Yeah, I realized.
So that looks finite, right? Now please explain to yourself how come B is infinite.
Because real number.
And what is the real number between 1 and 2?
Anything. Between 1 and 2.
And
So
how is that infinite?
what is like a billion decimals you can go into.
And you can still go more. And
Yeah.
you are correct. And you're correct. That's it. Okay. It doesn't get more difficult than this. It gets more varying. There's a lot of variation that they can do, but after a while, you think about it, you're quite okay. Okay, this is let's just take this as a math logic. Let's just put it that way. Okay. I'll see you tomorrow then. Will that be okay?
Yep, sure.
Try to do 1.5 hour tomorrow. If you're doing that, try to attend 8:30.
Yeah.
Okay. I'll see you then. Bye.
Bye.
Kyoko, are you okay? I mean, you're almost there, right? You're almost there because your first part is already correct, yes. Because tangent pi over 4 is 1. In case you don't know, you just press the calculator, better one, right?
Okay.
You're very close. You are like seriously very close.
I don't get it. How you do the cosine?
First of all, have you done the tangent pi over 4? Do you know how to do it in your calculator?
Yeah.
Okay. Then you want 1 over cosine pi. Now, first of all, you're right. I think you write down wrongly, you know. It should be like, I'm sorry. It should be like that, you know. But you can do this in calculator, what? Okay? 1 over cosine pi over 4. Can what?
Oh, okay.
Right? Try. I mean, it's not a nice number though. So that's a little bit of issue. You notice that? It's not a nice number in your calculator.
Yeah.
So you are a little bit of issue because I think they want exact law. Do you realize that this is a special number?
Yeah.
So do you know what the number is? If you don't know, I'll just tell you right now.
No, I don't know.
1 over half pi over. I'm sorry, I better write it down properly. Okay, something like that. Now, this is not the answer yet. Will this be the answer? I am optimistic, but you have to deal with your surd here and your ln, your logarithm. So it's a bit of surd here, a bit of logarithm.
Yeah.
Again, let me tell you that you will be correct. This is correct. So what remains is not integration, but what remains is your surd and your logarithm. Clear, yeah?
Yeah.
Now, let me ask you about your integration, this technique. Do you think you understand quite well this question?
Yeah.
This means you're ready to jump to a exam level question. And the exam level question are sometimes slightly easier than this question. Slightly easier, sometimes. But they give you 8 marks, 4 and 4, 4 above, 4 below. It's a big deal in terms of mark. It is a slightly long work. Usually it's worth like the length of 5 marks. So it's actually not as long as an 8 mark working. And after a while, it does become kind of standard. What I'm trying to say is just practice a little bit more. You will feel you're used to it. I'm not saying that the other integration is not important, okay? But this one is not that difficult to get, and I want you to get more practice. Maybe not from the textbook, just you go get it from the paper, it's going to be fine, okay?
Yeah. Okay.
So I give my emphasis. As for the surd and the ln, we'll take care of it next time. If you can take care of yourself, good for you. Okay. Please ignore the next question. I think, please ignore the next question first. Okay, no need to do that now. Okay. Is your homework finished?
Yeah.
Will you have more homework for the holiday?
I have a revision package for A-Math for Sec 3 topics.
Okay.
Yeah.
Let's quickly talk about your holiday tuition. Yeah, just quickly. Yeah. Your dad keeps saying that you're not going anywhere. No trips, no nothing.
Not,
Right? No. Is that true?
I have to
Okay.
go back to school for like I think
Tell
they
me,
have
tell me.
a program to help the Sec 4 study. So I think I have to go back not quite a lot, but maybe a bit.
Yeah, what's the schedule? What's the schedule?
I'll look through it again and send you because it's quite like irregular.
Okay.
Yeah.
Send me the schedule. No, that's fine. If we can make use of it, that's good. The whole problem starts where that is useless, or even worse, make you tired without giving you anything, or confuse you even more. But if that is useful, that's good. No, that's just totally fine. We just have to arrange our lives around that. No problem.
Yeah.
Yeah. So, but other than that, which is a lot lah. But other than that, nothing else.
I don't think so. No.
All right. So let me put it this way: even if we just do normal tuition, actually no problem with. Correct. It probably won't be a problem lah.
Yeah.
Okay, understand. So I'll ask for a bit more when the time is right lah. I just see the schedule.
Okay.
For school, I'll see you on Sunday then.
Okay.
Okay. Bye bye.
Bye bye.
You too.